Hello, my lovelies! It's Susanna, and today I want to show you how to solve this problem. It was part of an exam in Germany that you have to pass at the end of 10th grade, so let's take a look at it together. The sketch shows the rectangle ABCD with diagonals AC and BD, the intersection point of the diagonals M, and the segment EF. So let's take a look at our sketch. Here we have our rectangle ABCD. We have the diagonals AC and BD, the intersection point M, and this segment EF. E lies on the segment DM, so the point E lies on this segment here, and F lies on the segment CM, so the point F lies on this segment here. EF is parallel to DC, so this segment is parallel to this segment, and the distance between DC and E is 2 meters. So the distance between this segment here and this point here is 2 meters. We have to be careful. They don't say that this part here is 2 meters. They say the distance, and this is always the shortest distance. So this distance here is 2 meters. And since this segment here is parallel to this segment here, this means that the distance between these two segments is 2 meters. And the question is, find the percentage of the area of the triangle MFE relative to the area of the rectangle ABCD. Okay, to be able to find this percentage, we first need these areas. So the area of this triangle MFE, that is this triangle here. We need to find the area of this, so I call it a triangle. And we need to find the area of the rectangle ABCD, so this whole rectangle, I call it a rectangle, and if we have them, we can find this percentage. The area of the rectangle, we can find it immediately because we know the length of these sides here. So it's 6 meters times 11 meters for this area, which equals 66 square meters for the area of our rectangle. Okay, we have this already. So now we only need the area of our triangle. So let's go to another page and try to find the area of our triangle. The formula for this is base times height divided by 2. So what is my base? What is my height? For my triangle here, I can pick EF as my base, and then I take this line here as my height that is perpendicular here. So I write down the formula like this. I have my base, so the segment from E to F, and I take the length of this segment and I multiply it by my height. What do I know about my height here? We know the length of this side of the rectangle, which equals 11, and we know that this point M here is the intersection point of the two diagonals. So this is the center of my rectangle, which means that this length here is half of the entire side. So 11 divided by 2 equals 5.5. But I don't need this 5.5 for my height because these 2 meters, I don't want them in my height. So I just subtract these 2 meters from my 5.5 and I get a height of 3.5, which I can write in my formula here. And then I divide this by 2. So now we only need the length of our segment from E to F. Let's go to another page here to try and find this length from E to F. Our small triangle here lies in a larger triangle here, and it looks like that these two triangles are similar. And it would be great if they were similar, because then the calculations were so much easier. So let's check this. We can take a look at the angles. If all the three angles are the same of these two triangles, then the triangles are similar. So let's start with this angle here. Is it the same in both triangles? Yes, it is, because this angle is part of this small triangle and they share this angle, so it is also part of this large triangle. So this is the same angle. Let's take a look at this angle here then and check it if this is the same here. Yes, it is, because these two segments are parallel and we have this line here. So these two angles are corresponding angles and they are of the same size. And the same on the other side here. This angle is of the same size as this angle because they are corresponding angles. So now we know that our two triangles here are similar, which is great because then we know that if we create the ratio of two sides of our small triangle and we create the ratio of two corresponding sides in our large triangle, then these ratios have to be the same. So let's pick two sides of our small triangle. Of course, we take the side that we want to find out. So the length of EF, we put it in here. And then we also know the length of the height of our triangle. So the 3.5, we put it in here as well. And now we only have to find the corresponding sides in our larger triangle. So to the EF side, to this side here, this parallel side is the corresponding side. It is of length 6, so we write it down here. And then we have to find the corresponding side to the height of the small triangle. And this is, of course, the height of the large triangle, which is of length 5.5, so we can put it in here as well. Now we have one equation. We want to find out EF, so let's solve for EF. We just have to get rid of the 3.5, so we multiply by 3.5 on both sides here and here. Here it cancels out and only the length of EF is left. And on the other side, we can put this in a calculator and get the result of 42/11. This is the length of our side EF. We go back to our area of our triangle where we want to find this. Here is our EF. We put in the result we just found, the 42/11. Calculate all of this and we get for our area of our triangle a value of 147/22. We take now both of our areas and go to the beginning and try to remember what we wanted to do here. We should find the percentage of the area of the triangle, so this area, relative to the area of the rectangle, so this area. So we take the area of the triangle and divide this by the area of the rectangle. And if we calculate this, we get a value of 0.1012 and so on. We shall find the percentage, so we have to take this number and multiply it by 100 to get the percentage. If we do this, we get a percentage of 10.12, and this is the percentage of the area of our triangle relative to the area of our rectangle. I hope you enjoyed it. I'm curious how you solve this problem, so please let me know in the comments. I wish you a wonderful day, and I hope to see you in one of my next videos. Take care!